Alrighty, so this webinar is entitled "Cracking the Data Analysis Plan." It really comes from really hundreds, if not thousands, of people that really struggle with what statistical test to use. Even if you've taken a stat class and they teach you about a test, they're not really pairing that research question with that test. Um, so it's a very common issue that folks run into. So, um, what typically happens? Students guess at the test, the committees can correct it, or sometimes the committee even gets it wrong, or they don't fully align the research questions and the statistical test. At the end of the day, you kind of can lose some time in that process. Some, even worse, sometimes, is um, not having a data plan at all. And which is problematic. So people go through their proposal, they get to their results, but they don't have a data plan, which also means that they really didn't know what the sample size should be. So you really should have in your methodology, a clear research questions or study aims, and then a clear data analysis plan, which is what statistical tests you're going to use, what are those assumptions of those tests, and and that should be in there. And then also the sample size associated with those tests. So I'm going to present a kind of a formula that I've been using, and it works um, virtually all the time. So, and essentially, the data plan is just the result of having study aims or research questions in statistical language, okay, and knowing the level of measurement of your variables. Having those two pieces of information kind of gets you to the correct data plan. And let me just drill into these. So the research questions can really be bucketed. You could probably put them in 20 ways, but there's three broad ways of bucketing the or languaging the research question. That is to say, hey gosh, is there a relationship between variable A and variable B? Okay. Are there differences on some variable? Okay. By some other grouping variable? Okay. And then does one or more variables predict some other outcome variable? Those cover 25 tests in there. Um, but the essential point here is that the language in the research question is what we're trying to focus in on. That narrows lots of things. Okay, so if you can phrase and really try to figure out, how am I associating these variables via I want to look at a relationship or differences or prediction. That's going to take you a long way. Once you have that statistical language, the other piece of information you need is really the level of measurement of the variables. Level of measurement come in three varieties: nominal, name only, okay, male, female, Republican, Democrat, Independent. You can have more than two, okay, more than two categories, but they are just categories, okay? There's no order, there's no hierarchy, and so forth. Just names, okay? Ordinal has categories and some order to it, okay? All right. Um, and scale, and I'm bucketing scale using the term scale, but it could also be called continuous or ratio or interval. Um, I'm all using those synonymously because when it comes to the statistical test, they're all treated equally. Okay. Um, okay. So once I have both those pieces of information, A relates to B, based on what my variable A and B is, you can see the resulting statistical test in the right-hand column. So if I'm looking to relate male-female with, high and low or diagnosis or no diagnosis or whatever, nominal by nominal, I'm in chi-square land. Just moving to the end of the list, if I'm looking at income as a dollar amount, okay, and savings as dollar amount, okay, I can run a Pearson correlation. So you'll all get a copy of this, but feel free to take a picture of this with your phone as well. There's only 3 slides like this and give you a little kind of a cheat sheet of what statistical test based on relationship kind of questions and based on the particular level of measurement of a variable. Okay, differences really often to t-test land and ANOVA land. Here, the first row, looking at some scale variable by some grouping variable that's nominal. I typically, distance run by male or female. I'm in t-test land, okay, independent t-test land. If you have 3 or more groups, hey gosh, I am looking at, time to run a 5K by younger, medium aged, moderate aged, and older aged. Okay. So then we're doing kind of a one-way ANOVA. Uh, the ditto, the next line, same thing, basically. And the only trick is when you get to that third row into the ordinal outcome variable, and when I say ordinal, it should be truly ordinal. Um, most Likert type items are technically ordinal, but are treated as scale more often than not. But if you have a truly ordinal dependent variable in that third row by some independent nominal variable, amend Whitney is the test. 3 or more, Crisco Wallace. Okay. And the last bucket of statistical tests is really all in regression land. And here you'll notice that that middle column, it doesn't matter what the independent variables are. By the way, they're also called independent variables or predictive variables. Okay. Um, so it doesn't matter what they are or how many there are. Uh, the driver of the type of regression test in that third column is driven by the dependent variable or the outcome variable, okay, in that first column. So if your dependent variable is a binary nominal variable, we're doing binary logistic regression, okay. Um, for nominal with 3 or more, multinomial, ordinal, and scale, when the outcome variable is scale, okay, then we're really doing a linear regression. Or if you have more than one predictor, they call it a multiple linear regression. Okay. All right. So, what kind of research question do you have? What are the levels of measurement? And if you have a grouping variable, okay, how many groups do you have? Okay. And then you can see the quick reference down below that we're kind of in chi-squares and correlations, Pearson and Spearman correlations and relationships. We're in t-tests and ANOVAs for differences, and prediction, we're all in kind of regression land. So Intellectus, which I'll show you in a moment, has a few functionality functions to help streamline these things. We have a built-in decision tree that kind of step you through the process. Once you go to do tests, there's different tests to be had there, builds in assumptions, as well as the interpretation thereof, and things come out at APA. For any old timers on this call who were raised on SPSS, uh, none of that happened. Well, you had the tests, you had the tests, but you didn't have the assumptions built in or the APA or decision tree. So it was really Intellectus, is an innovation beyond even current day SPSS. So I'll get to the demo. Melissa, do I have any questions to answer at the moment?
There is maybe one or two in the chat. One was if for regression, do you really need to dummy code a variable? And then there's maybe one or two others.
Yeah. So I am 95% sure so you don't have to dummy code. So it will take one of your it will dummy code automatically. Um, and it will use one of your categories as the reference category. Okay. Um, so it will automatically dummy code it for you. Okay. And what's the other questions here, Mel? Sorry.
I think you're good to move on right
Okay.
now.
All right. So, all right, let's just peek at the tool itself. So this is the tool, web-based. What we've been talking about is really around here, decision tree. Okay. And in fact, these three buttons are good for methodology kinds of things. Make this a titch bigger. Too big. All right. So, and here we just really present, again, these kind of differences or relationships or prediction. And you do have to know what your IV and DV is. You do have to know what your level of measurement is. Okay, so but you can play around with this. I presume everyone's going to get this for a day or so to mess around with.
Yep, everybody has access in the email I sent earlier today, and it'll be open through the end of the day.
Nice. So feel free, take 10 minutes and play around with this. You can't hurt it. Um, I want to look at relationships, and they're all scale variables. Okay, like I said, income and savings and dollars. We're doing a correlation. Okay. Um, so play around. I want to predict an outcome, and it's nominal. It wants to know if you have more than two levels. Okay. I'll say no. Okay, so we go to binary logistics. So it's bringing you from the type of question into the analysis below. Um, it's not going to bring you everywhere. Okay, it's not going to bring you to uh, I'll say more advanced analyses, but it does cover a vast majority of what students and even faculty are working on. While I'm here, once you know you're doing a particular test, you want to evaluate yourself to these other things. Um, so the data analysis plans for a binary logistic regression. So just to have kind of what the assumptions are there and the references. So that can be helpful, the downloadable and editable. You'll also want to know what the sample size is for your particular test. Again, so it's called the power analysis, and that's put under stick with binary logistic, a regression, binary logistic, and then you can kind of, get some idea of the sample sizes that are ballparks. Well, these are actually calculated, so they're not ballparked. Uh, Four different effect sizes. What I intended to say is that there's kind of a few ways of determining or figuring out which effect size. So at a at a theoretical level, you really want to see what the effect size is of those kind of variables in previous studies. That's going to help you determine which effect size to use. The other thing is kind of a practical thing that most people are not funded researchers, and even at the faculty level, most people are kind of doing it by themselves or with a team. So uh, so it may not be practical to get 177 people. So you kind of have to balance those two constraints what a theoretical sample size would be versus, hey gosh, there's no way I can get that amount of people. And that's, that could be a limitation of the study, but you'll get the study done. So, okay, so those are really kind of methodology pieces here. Okay. Um, I guess I'll just touch on the, once you move through the method, once you move through IRB, once you collect data, um, let me see if I can get to see what kind of data I have here. Well, let me just so with the project, you can get data in a few ways here. You can upload from different file formats. You can, paste in an Excel or some other flat file. And then for faculty, we have um, different courseware to accompany the software. And let me just pull up a data set if I can. What am I looking for here? Let's go by name. Okay. Let's see here. Pop, pop, pop. Let's just go to what am I looking for here? Oh, let's just do sure. So when you select a data set, you can see some of the uh, some variables to work with, like I think it says tooth growth, tooth length by supplement. Okay, and so this is just getting data in. Uh, Once you have your data in, you can then manage it from here. We also, if you upload it um, through the upload data, it will put you into a data cleaning wizard, which is pretty helpful, particularly for like Qualtrics um, data sets. But once you have data, you can also manually manage it. Here we have length by how many different kinds of supplements do we have here? By two different kinds of either orange juice or ascorbic acid. And I guess a question could be had here. Hey, gosh, are the differences on tooth length by the supplement that you use? So let's just put this in action. So the question is, are there differences, underscore differences, by some nominal independent variable? So if I go to the decision tree and restart, so I'm looking to explore differences by groups. Do I have more than one DV? Nope. No covariates? Nope. Do I have more than one independent variable? Nope. Does my IV have more than two levels? No, it just has the absorbic and orange juice. So uh, is there more than two levels? No. So I'm going to be doing a t-test. Okay. this, if assumptions were violated, would be one reason to use that. So I can go to conduct. I'll go right to my DV, which is length. I'm going to go to my independent variable, which is supplement. Notice the icons, by the way. So, so I'm looking to see if there are differences in tooth length by supplement. It's worth noting too that there is video tutorials here. In every one of these dialog boxes, be it in data management or plots or analyses, uh, you can evaluate yourself to them there. They're also under this question mark. Now, let me just click this through and get there. You can also get to them by clicking the question mark. Okay, and is a pretty large library, like 80 videos of 3-minute videos about doing different things. Okay, so just to know that that's sitting there. We'll get a video button icon up there at some point, but just to make sure you know what's there. Okay, so for our t-test, uh, many of the tests have assumptions. The tool identifies what assumption, what tests can assess it, it runs it, and then it interprets it. Okay. Other assumptions, the name of the test to assess it, runs it, and interprets it. And then the results. Um, Here, the t-test was not significant. Typically, that p-value has to be 0.05 or less. Okay. And this is one way to report that. Okay. Um, and you can see, although orange juice led to a greater teeth length, it did not do so statistically. Okay. And then you kind of see what that looks like graphically, and then you can download that. You can download that document. So that's kind of a quick rundown of the figuring out which tests and assumptions and sample size, and then also being able to either upload data or play around with the example data set. We didn't really get into management, but they're all kind of simple as well. Create composite scores with a variable calculator, download your managed data and so forth. Also plots, 10 typical plots. Also, pretty simple to use. Okay. Notice the video tutorials, notice the icons of interest. So just, not the best plot in the whole world here. Hang on. How's that doing for me? Does that help? A little bit better. Okay. So there's different plots to be had. All right. Questions, Melissa, any questions we have on board here?
I don't have any open right now, but also, feel free to put them in the chat, the Q&A, or if you want to just raise your hand, if you think that'd be easier to talk through your project, we can unmute you as well.
Fine. And then while I'm there, I'll also say that I'll put out the contact information for everybody. Our main phone number, website, which houses our 3 tools, um, free, needs assessment, QR code, and then contact information for Samantha for students, Ashley for faculty, and Melissa for general questions. And if you want to take a snapshot of that with your camera, that's fine too. All right. Any questions on board here?
I haven't seen any come in. We had a couple about upcoming workshops, so we are off of the workshops in July, in June and July, and then we'll come back with them in August. And I'll include a link when I email this recording to where you can see upcoming workshops and register for them.
And can you also direct them to our archived?
Yes, that's in there
Okay.
too.
Pardon?
Yep, that'll be in that email too.
Okay, wonderful. All right. Last opportunity for any questions that you're working on. Know that we have I believe we have a DMP workshop tomorrow, correct, Melissa?
Yes.
So if you're a DMP or have colleagues that might like to get some help about how to move from really your data to your results, feel free to join us tomorrow. Um, Melissa, can I get to the when you send this out, obviously you'll have those other webinars there as well, but are those listed on our website, our
Yep,
webinars where they can sign up and get joined?
they are, and they're in, it's in the email, and I'll put it in the chat too to everyone.
Okay. And just for me, and where would I find that here? So
Under resources and then training.
under resources and training. Okay. Awesome. Uh, and that would be for the DMPs,
Yeah.
quality improvements and evidence-based practice projects. Okay. All right. Terrific. All right. If there's no other questions, I'll wish everyone a good rest of the week, and we'll see you all tomorrow. All right, everyone. Stay safe and happy. All right. Bye bye for now.